So you're prepping for the CompTIA Tech Plus exam, and you've hit the database section. Ugh, I know, it can feel like you're just trying to memorize a dictionary. But it really doesn't have to be that way. Stick with me, because we're going to use some pretty unforgettable stories to make these concepts actually stick in your brain. That way, you can walk into that exam feeling totally confident. Let's get into it.
So here's our game plan. First, we're going to touch on why our data is such a mess to begin with. Then, we'll dive into the two big players, relational and non-relational databases, complete with some real-world disaster stories. After that, we'll talk about the absolute lifesaver that is backups. And we'll wrap it all up with a super fast review designed to lock this all in for exam day.
Okay, so why do we even need databases in the first place? Well, because without some kind of system, our digital lives just spiral into total chaos, right? I mean, just think about trying to find that one specific photo you took 5 years ago in your phone. Or imagine trying to run a shop using just a bunch of sticky notes. It's a nightmare. So let's start with the absolute basics.
Okay, first things first, and this is a big one for the exam, so listen up. You have to know the difference between data and information. Data, that's just the raw stuff, the random numbers, words, pictures. By themselves, they don't really mean anything. Information, on the other hand, is what you get when you organize that data into something useful, something that actually helps you make a decision.
And if you want a super simple way to lock this in your brain, just think about cooking. Data is like your raw ingredients. You've got flour, eggs, sugar, just sitting on the counter. It's just a pile of stuff, right? But when you follow a recipe, when you process it all in a structured way, you get information. Or, a delicious cake. It's a simple analogy, but trust me, it's a powerful one to remember for the exam. All right, story time. And this one's a doozy. It's about what happens when you have the best intentions, you want to be super organized, but you use completely the wrong tool for the job. It's a tale of good intentions gone horribly, horribly wrong. So get this, my friend is getting married, and it's a huge wedding. We're talking 500 people. She asks me to help, and then she hands me this monster of a spreadsheet. There's one tab for the guest list, another one for the RSVPs, another for who wants the chicken or the fish, and yet another for table assignments. It was just this tangled web of lists that had nothing to do with each other.
What could go wrong, she says. Everything. Literally everything went wrong. I'd change a guest's name on one sheet, but totally forget to update it on the table plan. We ended up giving the best man, a guy who loves steak more than life itself, the vegan meal. And the poor 5-year-old flower girl, we sat her at the singles table. It was pure chaos. All because the data wasn't linked. You change one thing, you had to hope you remembered to change it in 10 other places. And that whole nightmare is exactly why relational databases were invented. It's an organized storage system. Yeah, it uses tables with rows and columns, kind of like a spreadsheet. But here is the absolute game-changing difference. It links those tables together. So no more updating someone's name in 10 different spots. You do it once, and it's done.
Okay, the school analogy is your best friend for the exam. Let's break it down. Think of having two separate tables, one for the student roster and one for the class schedule. A row is just one student's complete record. A field is a column, like name or age. Now, the primary key, this is important, is the unique student ID number. No two students can have the same one. And the foreign key, that's the magic. It's the class ID number that sits in the student's table and creates a link over to the class schedule table. So here's the bottom line for your exam. You need to know when to use which tool. Spreadsheets, they're great for simple, small-scale stuff. One person, maybe a simple list. That wedding disaster, classic case of pushing a spreadsheet way past its breaking point. Databases are built for the big time. They could handle millions of records, thousands of users at once, and most importantly, they make sure your data stays accurate and consistent. Okay, pop quiz time. This is exactly the kind of question you're going to see. What does a primary key do? A, speeds up the internet. B, connects two tables. C, uniquely identifies each row. Or D, prints reports. Think back to that unique student ID number we just talked about. And the answer is C. A primary key has one job and one job only, to be the unique ID for every single row. Think of it like a social security number for your data. Now, why isn't it B? Because that's the classic trick question. Connecting tables is the job of a foreign key. They will try to trip you up with that on the exam, so be ready. Okay, so I'm fresh off the wedding disaster, right? Feeling like a database genius. I survived. So of course, I get a little cocky.
I decide to apply my brilliant new organizational skills to a totally different kind of project. And it did not go well. So my family decides I'm the tech guy now and puts me in charge of our family history project. And we had everything. I'm talking hundreds of old photos, scanned diary entries, even long video interviews with my grandparents. And I'm thinking, no problem. I'll just pop all this into my perfect structured relational database. I made these neat little tables with columns for photo, document, video.
Oh, it was a complete and utter train wreck. See, a relational database wants neat, tidy, predictable data that fits in its little boxes. How do you stuff a 20-minute video file into a tiny table cell? How do you file a handwritten letter that's part story, part recipe? It's like, imagine trying to file a song or a painting in a filing cabinet that was only built for standard text documents. The tool just didn't fit the job.
And that's where our other hero swoops in, the non-relational database, or as you'll probably hear it called, NoSQL. Its superpower is flexibility. It's built from the ground up to handle all that messy, unstructured stuff from the family history project. The documents, the images, the videos, everything that just refuses to fit nicely into rows and columns. So for the exam, how do you know when to pick NoSQL? You're going to look for keywords. If a question talks about huge amounts of data that's changing all the time, like from a social media feed, think NoSQL. If it mentions unstructured data like photos or videos, or semi-structured data like an email that's got text and attachments all mixed together, the answer is almost always non-relational. Let's try another one. You're working for a company and they need to store massive amounts of user-generated photos and videos for their new app. What's the best tool for that job? Is it A, relational, B, a spreadsheet, C, non-relational or no SQL, or D, a good old-fashioned physical file cabinet?
And the answer, you guessed it, is C, non-relational. The absolute second you see the phrase unstructured data in an exam question, your brain should just scream NoSQL. That right there is the key. That's how they test if you know the real difference between these two database types. Okay, last story. And this one's going to hurt a little for anyone who's ever pulled an all-nighter trying to get a project done. It's a short but very painful story about why we need an undo button for our entire digital life. Okay, picture it. 48 hours straight. I'm running on fumes and lukewarm coffee, coding this app. It was the most beautiful code I had ever written in my life. I finally finish. I lean back in my chair to admire my genius. And in that exact moment, my cat, Mittens, decides to take a nice, leisurely stroll right across my keyboard. She hits some bizarre, magical combination of keys that deletes the entire main file, and then she steps on the save key. All of it, gone. And that, my friends, that soul-crushing, cat-induced catastrophe is why backups are maybe the most important thing we're talking about today. The definition couldn't be simpler. It's a copy of your data. The homework analogy is perfect. If your dog eats your term paper, you're not totally sunk if you were smart enough to make a photocopy first.
Now, for the exam, you have to know these three main types. A full backup copies everything, every single file, every single time. It takes up the most space and takes the longest, but restoring is super easy. A differential backup copies all the changes made since the last full backup. And an incremental backup is the quickest. It only copies changes made since the last backup of any kind. But restoring from it can be a pain because you need the last full one and every single incremental one after it. I guarantee you will be tested on these differences. All right, one last quick check. Which backup type saves everything every single time it runs? Is it A, differential, B, incremental, C, full, or D, temporary?
Yep, the answer is C, full. The name really does say it all, right? It's the full picture every time. It's a common question, so make sure you've got that one down cold.
Okay, you've heard the horror stories, you've got the tech details. Now let's do a final rapid-fire review to really lock all this information in your head for test day. Let's do it. Let's strip this all the way down. Super simple. Primary key, that's your unique ID. Foreign key, that's the link between tables. A query, that's just you asking the database a question. A report, that's the database showing you the answer. And a backup, that's your safety copy. Simple as that. Seriously, think of this as your secret decoder ring for the exam. When you're reading a question, hunt for these trigger words. If you see rows and columns or structured data, you should immediately think relational. If you see flexible or unstructured data,
Your brain should go straight to non-relational. Making these fast connections is the shortcut to getting the right answer under pressure.
And look, here's my last piece of advice. The questions on the exam always give you clues. If they're talking about IDs or linking tables, you know the answer is going to involve primary and foreign keys. If they give you a whole scenario about when files were saved and how, you know it's a question about full differential or incremental backups. Just break the question down, find the clues, and you'll be fine. You've got this.
So I'll leave you with this question. Now that you get the power of organizing data, what's the first messy part of your own digital life you're going to tackle? Is it that chaotic folder of photos on your desktop? Your music collection? Applying these concepts even in small ways is really the best way to master them for good. Thanks for hanging out, and good luck on your exam.